Hello students, good morning everybody. Today we will discuss about integration. In that point, methods of integration, and one of the method is integration by part. When we apply integration by part method, if integrand quantity is the product of two different functions, that time we use integration by part rule, and the rule is like this. Okay, so rule is like this: integration of u v dx is equal to u integration of v dx minus integration of derivative of u into integration of v dx into dx. If integrand quantity is the product of two different functions, that time use integration by part rule or by part method. This is one of the important method in integration. Suppose u is the first function and v is the second function, then how to remember this integration by part rule? Integration of first into second dx is equal to first function into integration of second function minus integration of derivative of first function into integration of second function into dx. Okay, then how to do proof? Proof is like this: if u and v are differentiable functions of x in single variable, then the derivative of u into v is d by dx of u into v, which is equal to u derivative of v plus v derivative of u. This is the product rule. Okay, that integrating both sides, we get integration of d by dx of u v into dx is equal to integration of u into dv by dx into dx plus integration of v into du by dx into dx with respect to x. That's why I written dx everywhere. Okay, but you know, integration is the reverse process of derivative. Therefore, automatically derivative integration gets cancelled, only remaining uv equal to integration of u into dv by dx plus integration of v into du by dx into dx. Okay, transfer this second term in left hand side. I will write down in this way. Integration, I will written this step first. U dv by dx into dx is equal to what? You can write down uv minus, transfer this term on that side, integration of v into du by dx into dx. Try to understand this step clearly. Okay, I have transferred this second term in left hand side. I have written in this way. Okay, give this equation number 1. And you can suppose or let u is nothing but f of x. U is nothing but f of x and dv by dx is nothing but g of x. dv by dx is nothing but g of x. Therefore du by dx is equal to f dash x. Derivative of u with respect to x is f dash x. And what about integration of this? Integration of g of x means integrating both sides. What is the integration of this? integration only is equal to and v equal to integration of g of x dx. Integration of g of x dx. Therefore, put all these values in equation 1. Therefore, equation 1 become in left hand side integration of what is value of u? U is nothing but f of x into dv by dx is nothing but g of x. G of x into dx is equal to what? U into v. What is value of u? U is nothing but f of x. First function keep as it is f of x, and v is nothing but integration of g of x dx minus integration of v. What is value of v? Integration of g of x, and du by dx. Du by dx is nothing but f dash x. Multiplication commutative, that's why I written f dash x into integration of g of x dx, and one more dx is also there. Okay, this is the integration by part 2. Means you can remember in this way also, integration of first into second function into dx is equal to first function keep as it is, integration of second function into dx minus integration of derivative of first function into integration of second function into dx. Okay, this is the integration by part rule. You can remember by using first and second function, or by using f of x into g of x, or by using u into v dx also. Okay, this is the proof of integration by part 2. Okay, but how to select first and second function? That is very important, otherwise your question is not end. Okay, selection must be proper. How to select u and v? How to select first and second function? How to select f of x and g of x? How to select u and v? By using order of letters L, R, A, T, E, or sometimes they are written I, L, A, T, E, ILATE, or LIATE, where L means what? L means logarithmic function. I means what? I means inverse function. A means algebraic function. A means trigonometric function. And E means exponential function. Okay, some they are given in this way or in this way, ILATE doesn't matter, but you must be select first and second function by using order of letters LIATE. Means easily you will get the answer. Okay, let us take some example depending upon this. Example 1 is like this. Evaluate integration of x sec square x dx. Observe this question carefully. Here x is one of the function. And sec square x is another function. You can select first and second function by using order of letters LRATE. X means algebraic function. Sec square x is trigonometric function. Algebraic function and trigonometric function. What is the order? Order in case of LIATE. Here algebraic first, then trigonometry. Algebraic first, then trigonometry. That's why in algebraic function you can select first function, and in trigonometric function you can select second function. This is the order of selection of order of letters by using order of letters LIT. Using integration by part rule. And the rule is like this: first into second dx is equal first integration of second function into dx minus integration of derivative of first function into integration of second function into dx, because this dx for this integration and this dx for this integration. As per this rule, you can write down, I is equal to, given integration is equal to, integration of first into second dx is equal to first means x, integration of sec square x dx minus integration of derivative of first function means x, into integration of second function sec square x dx, and one more dx is also there. Okay, then take integration using by standard formulas. X as it is, what is integration of sec square x? That is nothing but tan x minus integration. What is derivative of x? 1. Not necessarily write 1. What is integration of sec square x? Tan x into dx, which is equal to x tan x minus, what is integration of tan x? Remember formula? There are two different formulas for integration of tan x. One of them is minus log of mod of cos x plus c, and another is log of mod of sec x plus c plus some constant of integration. This is the answer for this question, isn't it? Got it, everybody? Okay, selection is very important, and then remember the formula. As per formula you can write and take integration, you will get the answer. Okay, then one more question for practice. Evaluate integration of x square e raised to x dx. First of all, let I equal to integration of x square e raised to x into dx, and select which is the first function and which is the second function. Which is the first function and which is the second function. You can select properly by using order of letters LIT. Here, algebraic function. X square is nothing but algebraic function, and e raised to x is nothing but exponential function. In the order of letters LIATE, algebraic come first and then exponential come at last. Therefore, this is the first function and this is second function. You remember integration by part rule, first or second, or you can write in this also u and v. U is the first function, v is the second function. Okay, by using by part rule, integration by part rule, I is equal to first function, or you can write integration by part rule, and the rule is like this: u v dx is equal to u integration of v dx minus integration of derivative of u into integration of v dx into dx. Okay, as per this rule, you can write down first function as it is, integration of second function into dx minus integration derivative of first function integration of second function into dx. means u integration of v dx minus integration of derivative of u into integration of v into dx. Then take integration, you will get x square. What is integration of e raised to x? E raised to x. Integration of. What is the derivative of x square? That is nothing but 2x. Derivative of x square. Integration of e raised to x. E raised to x into dx. Okay, which is equal to x square e raised to x minus, take 2 outside the integration, use bracket and write x e raised to x dx. Try to understand how to take integration of this. Here is also product of two different functions. One of them is algebraic, another is exponential. That's why again apply integration by part rule, which is nothing but x square e raised to x minus 2 into bracket. First function, this is the first function, this is second function. First function, integration of second function dx minus integration of derivative of first function into integration of second function into dx. Complete the bracket. Okay, then I have written here I is equal to x square e raised to x as it is minus 2 is also as it is. Then take integration, means you will get x as it is. What is integration of e raised to x? E raised to x minus integration of derivative of x 1, not necessary write 1. Integration of e raised to x, e raised to x into dx. 1, not necessary write 1. And again take x square e raised to x minus 2 into bracket x e raised to x minus e raised to x plus some constant of integration. Again simplify, open the bracket, e raised to x minus 2x e raised to x minus plus 2 e raised to x plus some constant of integration. Again you can write in this way, I is nothing but e raised to x take common, you will get x square minus 2x plus 2 plus some constant of integration. This is the final answer for this question. Suppose here x cube is present, apply integration by part rule 3 times. Here x square is present, that's why apply integration by part rule 2 times. Similarly, you can simplify in this way. Is that it? Okay. Then take one more example. Again, it's like this. Try to understand guys, this it is one of the important chapter in integration. Okay, next question is like this. Evaluate integration of x tan inverse x dx. Let I equal to given question x tan inverse x dx. Isn't it? You can select. Selection is important. L-I-A-T-E. L-I-A-T-E. Here, logarithmic inverse. Inverse is first, then algebraic then second. Means, suppose this is the first function, this is second function. This is first function, this is second function. And by using by part rule, as per rule, I am not written here, but you must be remember rule properly. First means tan inverse x as it is. Integration of x dx minus integration of derivative of tan inverse x. Derivative of tan inverse x into integration of x dx into dx. Okay. Then simplify step by step. Tan inverse x. What is integration of x? You will get x square by 2 minus integration of derivative of tan inverse x 1 upon 1 plus x square integration of x number x square by 2 into dx, isn't it? Means you can write this way, x square by 2 tan inverse x minus, take 1/2 outside the integration, and which is equal to x square divided by 1 plus x square into dx. Isn't it? I am taking constant term outside the integration only. Then what can I do here? Here degree of numerator is 2. Degree of denominator is also 2. It is improper fraction. Use actual division method or by adjustment method, because degree is same as well as coefficient also same. If degree and coefficient both are same, use adjustment method, which is equal to x square by 2 tan inverse of x minus 1/2 integration of plus 1 plus 1 plus x square minus 1. This is the adjustment. X square is as it is, plus 1 minus 1, and divided by 1 plus x square into dx. Okay, collect these two terms together and separate the denominator. You will get I equal to x square by 2 tan inverse of x minus 1/2 into bracket. When we separate, divide 1 plus x square divided by 1 plus x square means 1. You will get integration of 1 dx minus integration of 1 divided by 1 plus x square into dx. Okay, which is equal to, I have stated, separating denominator. These two terms divided by 1 plus x square gets cancelled, 1 minus 1 divided by same denominator. Okay, take integration. You will get x square by 2 tan inverse of x minus 1/2 into bracket integration of 1 dx x. What is integration of this? Tan inverse of x plus some constant of integration c, which is nothing but x square by 2 tan inverse of x minus 1/2 x, or you can write x by 2, and minus 1 is plus 1 upon 2, or write down tan inverse of x divided by 2 plus some constant of integration c. Okay, this is the final answer for this question. Got it, students? Okay. Then take another question. For better understanding, you have that integration of log x bracket square into dx. Log x bracket square into dx. How to solve this type of question? First of all, observe the question carefully. Integration of log x bracket square into dx. Here only one function is looking to you. Then how to use integration by part rule? I is nothing but integration of log x bracket square into dx. Only one function is looking. Integration by part rule, we can apply if integrand quantity is the product of two different functions. What about the other function? If other function is not given, you can suppose one is the other function. And then apply LITE, order of letters. L means logarithmic is the first function. This is the first function, and this is second function. And then apply integration by part rule. And the rule is like this: first function keep as it is. Integration of second function minus integration of derivative of first function into integration of second function into dx. Okay, which is equal to log x bracket square. What is integration of 1 dx? X minus integration derivative of log x bracket square. What is the derivative of this? Take index in front of 2 log x raised to 2 minus 1 into derivative of log x 1 upon x, composite function. 2 log x raised to 2 minus 1 into derivative of log x 1 upon x. What is integration of x? Integration of 1 dx is nothing but x into dx. Cancel this x, which is equal to x log x bracket square, x log x bracket square minus 2 into integration of log x into dx. Because x automatically cancelled, constant of integration take outside the integration, constant term take outside the integration, only log x is there. Again you will get only one function. Another function you can suppose 1 is the other function. And select by using order of letters LIT. This is the first function, logarithmic function is the first function, then algebraic function is the second function, and again apply by part 2, integration by part 2. And that rule is like this: x log x bracket square keep as it is, minus 2 is also as it is, and then apply integration by part 2 again. Log x integration of 1 dx minus integration of derivative of log x into integration of 1 dx and 1 more dx. Okay, then take integration, you will get the answer. I is nothing but x log x bracket square minus 2 times log x keep as it is. What is integration of 1 dx? X. This log x as it is. Integration of 1 dx is x minus integration. Derivative of log x. Derivative of log x is nothing but 1 upon x, and integration of 1 dx is nothing but x dx. Cancel this x term, means I is nothing but x log x bracket square minus 2 times x log x. I am multiplication commutative, that's why I am writing first x log x minus integration of 1 dx. Means your final answer is like this: x log x bracket square minus 2 into bracket x log x. What is integration of 1 dx? Again x plus some constant of integration. Open the bracket, you will get final answer is like this: 2x log x minus plus 2x plus some constant of integration. This is the answer. This is one of the important question for JEE examination also. Okay, this is the one of the important method, integration by part 2. Okay, thank you.